Good afternoon, students. Can you see the screen and hear me? Hello?
We can hear you, sir.
All right, good. All right, so we're going to do a short topic today. Topic because we're online. I didn't want to do a topic that required too much. This is a topic almost like it is best. It's almost like it is taught by example in the main. Right? Theory wise is not a lot. Right? And you can basically see it on this slide here, on this page here. That has some notes about what Loci is. Loci is a plural of the word locus. So talk about the locus of a point. The pen giving me some problem. Let me see. Locus is singular. Loci is plural. Alright, or loci. So what is locus? Or what is the locus of a point? It says here. So basically, let me say it in my own words first, what locus is. So the locus of a point is the path which can be a line or a curve that a point will stay on under a given condition, such that points on this curve or points on this line satisfy a particular given condition. The equation of this line or the equation of this curve would be the locus of that point. And you can get the equation of this line or curve in terms of x and y if you call that point pxy. So like we define conditions that define how the point moves. Let me give you a simple example. So let's say one of the simplest example is that a point P, and you always call that point xy, where the x and the y represent general points, represent all points that a point is going to move on. So you call it xy, because not just one point. So let's say a point P moves such that it is a fixed distance. One of the simplest example are points that move such that it's a fixed distance of 3 units, for example. So 3 units from some other point, so some other point 2, 4. So you want a point that is moving such that everywhere that point is, it's going to be 3 units from this point. It means that this point, the locus of this point has to be on a circle where this is the center. If I put on this point as a center, then I'm moving such that I'm always 3 units from this center. It means that I'm moving on a circle. I'm moving on a circle such that everywhere from this point, the distance is 3 units. So we would be on a circle where the center is 2, 4. The center is 2, 4, and the radius is 3. So the equation of this circle would be the locus of the point P. What would be the equation of that circle? Based on what we know. It will be x minus 2, that's the x value at the center, squared plus y minus 4, which is the y value at the center, equals this radius squared, which is 3 squared. That will be the locus of this point, the point P, that is moving such that it is a fixed distance of 3 units from this point. This equation that we get will be the locus of that point. So the equation that the point moves on, or the equation of the curve or line, or the path that the point takes to satisfy the given condition, is called the locus. Now, How could I prove that this is a locus if I didn't know it was a circle of center 2, 4? And I didn't know that the equation of a circle when I know the center and the radius was this. Suppose I didn't know that. You could still work it out. Because all you'd have to do is apply a coordinate geometry strategy. Note what I've said. You apply the topic. A locus really is an application of coordinate geometry. It's a topic where we're applying coordinate geometry knowledge, coordinate geometry techniques. So what you generally do, you call the point that you want the locus for P, X, Y. And then you apply what they have said here. So all we would do is just do a calculation such that the distance between this point and this point is equal to 3 units. And you would end up getting this equation down here. So let me show you now how you would do that. So based on what this said, you want the point PXY to be 3 units from the point 2, 4. It means that the distance between these 2 points is always 3 units. Now, what's the formula for distance between 2 points? That's what we're going to apply now. The formula for distance between 2 points. The formula for distance between 2 points is the square root of the difference in the 2x value squared, which is this minus this squared, plus the difference in the 2y values, which is this minus this squared. That's the distance between those 2 points, you know. This is the distance between the 2 points. And we are saying it is equal to 3. And if I square both sides now of this, I'm going to get x minus 2, squared plus y minus 4 squared equals 3 squared. And you should recognize now that that is the equation of a circle, which is what you would have. So the equation and what rationally happens kind of makes sense. Right? They're in sync, they're consistent. Because if you're moving such that you're the same distance from a fixed point, they must be moving around that point on a circle. And if you use a method of calculating the distance between 2 points, where you call the locus point PXY and the given point 2, 3, 2, 4, and you write an expression for the distance between them, and you put it equal to 3, you end up getting this equation. And that equation would be the locus of the point P. Simple as that. This is a simple example. And I gave you the distance between a point, a fixed distance. But you can say, okay, a point moves such that it is the same distance from 2 lines. A point moves such that it is always perpendicular from 2 points. A point moves such that it is always 3 times the distance it is from one line as compared to from another line. Various things I can tell you. And all you need to do is apply a coordinate geometry strategy. Interpret what they have said, call the point that they are talking about, PXY, and apply a coordinate geometry strategy, and it will work out itself. Think you understand what I've said so far, guys? Think you have understand? I'm going to do some examples. You know? That's all that we need to do. If they say a point moves such that it is the same distance between 2 points, say you have 2 points A and B. And I think that's what this example is. Let me see. See there, this example. Look at this example right here. It says a point P is restricted to be equidistant from this point and from this point. Right? So you call the point P, XY. This point is A, which is 1, 2. And this point is B, which is minus 2, minus 1. And all they have basically said that the distance AB, AP, will always be equal to the distance AB, BP. Because P is the same distance from these 2 points, right? So the distance AP and the distance BP is the same. What's the expression for the distance AP? Distance for the expression for the distance AP between these 2 points is the square root of this x value minus this x value squared, that's x minus 1 squared, plus this y value minus this y value squared, y minus 2 squared. That's the distance AP right now. It is equal to the distance BP, which is now the distance between these 2 points, which again becomes the square root of x minus a negative 2 becomes x plus 2 squared plus y minus a negative 1, which becomes y plus 1 squared, y plus 1 squared. And because these two sides are square roots, you can square both sides and drop off the square. And so you get x minus 1 squared plus y minus 2 squared equals x plus 2 squared plus y plus 1 squared. That is the locus. And if you like, you can expand it out, transpose, simplify, and all of that. Which is what is done on this example over here. Right? See it here? This is what they have. See it here? This side equals that side. See it here? That's what we have right here. This side, which is this, equals this side, which is this. And then when you expand out, simplify, and so on, you end up getting one line. It comes down to this if you simplify this. But let's see if it makes sense. Because look, if you have 2 points, A and B, and you're moving such that you're the same distance from the 2 points, they must be moving along the perpendicular bisector between the 2 points. So the perpendicular bisector there. You must be moving on the perpendicular bisector between the 2 points. This line, if you're on this blue line, if there's a point P on this blue line, PXY, then to be the same distance from this as from this at all points. And this line will be the perpendicular bisector from A to B. So instead of doing the calculation as I did here and simplifying this to get this equation that I have here, which is 0, which is x plus y equals 0, right? It becomes x plus y equals 0. This equation reduces to x plus y equals 0. X plus y equals 0 will be the equation of this line. So you could have just calculated the perpendicular bisector between these 2 points of the bat if you recognize that is what the locus would be. But you don't have to. You can follow what they have said and apply a coordinate geometry strategy, call the point P, and put what they have said into calculation, as I did here, and then simplify it right down itself. So it is your ability to interpret what they have said, call the point that you want to find the locus on, PXY, interpret what they have said, and then use a coordinate geometry strategy to do it. Now, one way of interpreting what they have said correctly is to always make a sketch, a coordinate geometry sketch to represent what they have said, and then you apply a coordinate geometry strategy. A lot of the times, it's about distance. Sometimes it's about gradient. Sometimes it's about angle. Right? So, your ability to read the information that they give you, the restriction of how the point is moving, and set up a diagram that reflects what they have said, and then do your calculation from your diagram, then you're good to go with this topic and you don't have no problem. But there's one thing I want you to memorize, and I've not seen a CXC question yet in pure maths where it was absolutely necessary to use that formula. It was a good formula to know. And that formula is a formula for the distance from a point XP, YP to a line of the form, what line equation going on? AX plus YB, AX plus BY plus C equals 0. So you want the equation to be like that. When your point is xp, yp like that, and your line is in this form, then this distance, which is the perpendicular distance from a point to this line, let's call that L. That distance L is equal to, so like you write back this equation, but you're putting in these coordinates on it. You're putting in these coordinates on it. So it becomes equal to this. Pay attention now. It becomes AXP, that's x value at this point, plus BYP, that's y value at this point, plus C. So you see, I have to write the equation in this format. Right? It's going to work out to a value. They divide this by the square root of the xp squared and the yp squared. This is a formula that I need you to memorize. I think I have it on the slide somewhere. Let me see if I have it done. It's supposed to be done. See it here? This is it. Yeah, that is it, guys. Oh, and it's plus or minus. You know it's plus or minus? Because you don't know which side of the line the point is on. The point could be over on this side over here. The point could be over on this side of the line. Your XPYP. And that's why I have to put plus or minus, because it can be on the other side of the line. So this is the formula for the perpendicular distance from a point to a line. And when they say the distance from a point to a line, it is always a perpendicular distance they are talking about. It is understood to be a perpendicular distance. So this thing has, you know what, let me send you this. I'm going to send you this document, guys. Let me send it in the group now. Let me send this document into the group right now so you have it. So I don't forget. This document that I'm working with, let me send it in the group. I should have sent it before. Let me send it in the group right now as we speak. Where is it? Where is it? Where is it? Give me a second, let me find it for you. I had it. Pure maths. Hold on a second, let me find it and send it in the group. I think it is this one. Let me send it in the group right now. Let me first see it. Oh, I sent it earlier. I sent it earlier, man. It's the same document I sent earlier where I said notes for the locus. Okay, so let me delete this. I sent it earlier. I didn't realize. I sent it in the group earlier. I didn't realize I sent it. So it's that document. And this is on it. This is on it. So this is basically the only thing that I needed to like memorize, this formula right here. For the distance from a point to a line that is in this equation. And then I have a nice example right here. That's an example. The distance from this point to this line. So if you give the equation of a line in any other format, I want you to transpose it to look like that. And then this becomes the distance. That's the expression for the distance. Right there. Alright? So they ask for the distance to this, and you're good to go. Alright? So I'm going to show you how to use locus on a question now with using this information. You know. Or the distance from this point to this line would be this. So what I do, I put back the equation right up here. But I'm putting in these values, the x and the y value. That's what I have here on the equation, right? So I put them in back here. So this x value goes here, this y value goes there. And you're dividing by the square root of this value squared. Oh, sorry, it's the wrong two. This value squared and this value squared. Oh, it's the a and the b. So I have the wrong form over here. It's the a and the b I should have under here, not xpyp. My mistake. So it's the a and the b. Alright, good. So it's a squared plus b squared, which are the coefficients of the x and the y under here. So this would be the length, the distance from this point to this line. And it can be plus or minus. Right? Plus or minus. Right? It can be plus or minus. Let me see if I can show you why it is plus or minus. So it's basically two distances. Let me see if I can figure out and show you how it could be two distances from this point to this line. So if you have a line like this, draw a line like this. I have a point up here. Why is it 2? Why is it plus or minus? Why is it plus or minus? We're talking about this distance to that line. So if that is a line, it's this distance is a perpendicular distance. I don't know. I'm not seeing why it's plus or minus right now, but yeah, it would plus or minus. I guess maybe one of the distance wouldn't be valid if you work it out. Plus or minus depending on which way you're looking at it. I could be looking at the distance this way or looking at the distance this way. I guess that's why it's plus or minus. But for the purpose of calculating on a locus point that you don't know, so for the purpose of if you don't know exactly where this point is, and let's say they tell that the distance from a point P xy to this line is 2 units. 2 units. They tell you it's 2 units. It means that it could be 2 units over this side as well. It could be 2 units over this side. Right? That's why you have to put in the plus or minus when it's at a point that you don't know. Alright? But this one, the plus or minus depending on how you look at it. Right? But for the purpose of finding a point here, you don't know. You have to consider that it can be plus or minus. Alright? So here's an example now that applies this knowledge. Here's an example that applies this knowledge now. So this question is a low-cost question. Look at it. Right? Look at it. This one right here. Put a box around it. And I said I've not seen them set question with distance from a point to a line like this before in PERMAS. Alright? I'm not seeing them set one where this formula becomes relevant to use. The question says, the point PXY moves such that its distance from this line is always equal to 7. So this time now they're telling what the distance is. So from a general point to this line, the distance is always 7. And they're asking you to find the locus of that point. So because you don't have the values on this point, that's why I put a plus or minus, because it can be on the left side of it, on one side of the line, or on the other side of the line. So what you need to do is set up a formula where the distance from this point to this line is equal to 7, which is what I have here. So because this point is x and y, it's like this x comes back here for this x, so you have back the x there, so. And this value comes back here for the y, that's why you have back the y there, so. So it's like you put back the entire expression for the line up here. And you divide that now by the square root of this squared plus that squared. Put a plus or minus on it, and you put it equal to the 7. And if you simplify this, that's a locus that they want. See, that is the locus of the point P. Think we understand that, guys? Simple as that. Think we understand that? So this thing up here, guys, I need you to memorize this thing in the box right here. Memorize this. That's the distance from any point to a line like this is given at this. So if you don't know what the point is, if you don't know the point, they like you're writing by the full expression back up here, so. And then divide it by the square root of this value square plus that by the square. And you put it equal to whatever distance they tell you. The distance is 6, you put it equal to 6. And that becomes the locus of that point. And all we need to do now, guys, is just run through some examples. So I'm going to do some examples that I have on the screen, or on the document I gave you, and the solutions I already did, but I'll work them out again. Right? And I might actually use a different method to work them out. But I want to show you what the thought process is. And it's always good if you can make a sketch of what they have said. Do a sketch to represent what they have said. Call the point XY, and then you're applying a coordinate geometry strategy to do it. And the only coordinate geometry strategy I don't show you yet is the distance from a point to a line, which is this formula right here. That's the only thing I don't know. Everything else in terms of a coordinate geometry method, you already know. So I'm going to do some of the examples now that's on the sheet, and then I'm going to look at the past paper. Now, it does not come on every exam paper now. I mean, they can't set everything. The syllabus is so long, it is impossible for them to set everything every year. So you're not going to find locus on every exam paper. And when it comes like a 4 marks question, it's part of a question, right? Because they just ask to find the locus of a point through some condition, right? So what I'm going to do, I'm going to work through the questions on the screen here first, and that was in the handout, and these are the solutions for those questions, right? And the questions are up here. So you already have the solutions, or you already have a solution for each of them here on this handout. That's something that I worked out before, and I gave to students in previous years. I didn't make any notes because locus was not on the syllabus originally when we started Pyramus, and then it came onto the syllabus. All right, so that's why I have this thing in this format. But these are the questions. These are some examples right here, right down here. These are some examples. Question says, find the Cartesian equation of the locus. When you get the equation in terms of x and y, that's the locus of a point P. To get it, you call the point Pxy. Call the point Pxy at all times. Alright, and using a coordinate geometry method to get a relationship between the x and y. So you say P, the point P is equidistant from this and this line. Alright, let's set up this one now. So you want the point P to be the same distance from this point and from this line. Now, see lines like that, which is just a vertical line, kind of easy to work with. Vertical lines and horizontal lines. When you want distance on those lines, kind of easy. Because look at it now. If you have the line x equals minus 2, I have a point, say a point over here, P. xy, right? It means that at this distance, the perpendicular distance from it, means that this point has the same y value as this. So this will be minus 2 is always x value on a vertical line, and this y value is y. So it means that this distance is simply the difference between this and the minus 2. So that distance might be, for example, x plus 2. That's what this distance would be, x plus 2. Alright, so when you have vertical lines and horizontal lines, it's kind of easy. Alright, so we don't need to use a formula that I just showed you for vertical and horizontal line. But let me set up this one and work it out and show you. Alright, and as I said, we want to sketch the situation. We want to make a sketch of the situation and use a coordinate geometry method to work it out. Alright, so I'm going to sketch this situation. When you sketch it out, it's a lot easier to do. And try and make it as realistic as possible. And always call the point Pxy. Call it xy. And you're trying to sketch it. Alright, so you have the point 4, 1. And you have the line x equals minus 2. So watch this now. And you always want to put your point P in the positive quadrant over here. So always put a point over there. Make it work out itself. Always put your point over there. When you make your sketch, and you set up your coordinate, the Cartesian coordinates, put your point P. Set it up so that you put your point P over here with the x and y value positive. Make the values work out themselves. Alright, so use that also as a rule. Alright, so let me set up this one now. So we have a coordinate geometry system based on this question. And we have the point 4, 1. So 4, 1 is over here. So 4, 1. And we have the line x equals minus 2. And x equals minus, put on in purple. X equals minus 2. We have vertical line over here. X equals minus 2. I'm going to put my point P down in black. I'm going to put my point P somewhere here. Call it xy. And this distance is the same as this distance. Now remember, the distance from this point to this line is a perpendicular distance like this. So this is perpendicular. Alright? Now since this line is x equals 2 and this is on a horizontal line, the y value here and the y value here is the same. So it means that this point right here will be minus 2y. If I call this point xy. And these two distance, not so perfect. Maybe shift this y-axis a little bit more over. No. I'll bring this closer. Let me bring this closer. I kind of look a bit too far. I want to look kind of real, like it's the same distance real. Let's put that line right here, such that this length, and this length is the same. And then this point, as I said now, is this. That's the setup. So all you need to do now is get an expression for this distance. Get an expression, use a different color. Get an expression for this distance, an expression for this distance, and you put them equal. That's all you have to do, and you simplify. But that would be your sketch of what they have said. That's the x-axis and that's the y-axis. And they said that the distance of this point from this line, which you are talking about, this distance here, is equal to the distance from this point, which is this distance here. So this is a good sketch of what they have said. Now what will be this distance? Over here so is x, and over here so is 2. So the distance from here across here so is x plus 2. Or you could say it is x minus a negative 2. In any case, this distance is x plus 2. So we can say x plus 2, that's this distance, is equal to the distance between these 2 points now. Length of line formula now. So length of line formula now says that this distance is a square root of the difference in the x values squared, which is x minus 4 squared, plus the difference in the y values squared, that's y minus 1 squared. This is your locus. And all we have to do now is simplify this. Simplify it down to lowest terms and get the equation of it. But that's your locus. And if we proceed to simplify it down, I can get rid of the square root by squaring both sides first. So I'll get x plus 2 squared equals x minus 4 squared plus y minus 1 squared. Can expand this side and get x squared plus 4x plus 4 equals, expand this and get x squared minus 8x plus 16, expand this and get y squared minus 2x plus minus 2y plus 1. Simplify. So this x squared wipe out this x squared, them 2x squared wipe out each other, so the x squared them gone, right? So let me underline them in red. So this and this wipe out each other. And then we have, let's consider the x values. So this x value come over here, add to this to give me 8x. 8x. No, 8 and 4 make 12x. So we get 12x. Then now, this and this are 17. 17 come over here, so I get 4 minus 17 is negative 13. Alright? Negative 13. So we have minus 13. And that will be equal to, this is left, y squared minus 2y. Y squared minus 2y. That's it. I mean, you can simplify it further, but that is good. Let me see what answer I left on the paper down here. So for this one, when I did it first. Alright? Because the same thing. See there? The same thing. So I left this, see there? Same thing. Alright, so if I transpose everything back over this side, I'm going to have y squared minus 2y minus 12x. Okay, over the 13, we get plus 13 equals 0. Same equation I have back here in that example. But the same method. Think we understand that, guys? So this solution is you already have it. So you don't have to write off of it. You don't have to write it off. You already have it. Understand that, guys?
Yes, sir.
Alright. I want to get through this so we can get to the past papers now. So you see that the past paper ones is nothing really. And then I might ask you to do a couple examples. Important thing is that you work them over by yourself. Alright. The next question is that typical question I like to set. So we just did number 1, right? So we're number 2 now. P is equidistant from those 2 points. P is equidistant from those 2 points. Right? So it's going to be a perpendicular bisector between them. But you're going to use the method that they said. So let's say that the first point is A35. Then you have P in the middle, XY. And then you have the point B, minus 1, 1. And what they're saying is that this distance is equal to this distance. Those two distances equal. AP is equal to BP. That's what they have said. So all you have to do now is get an expression for the distance AP using length of line formula, which is the square root of x minus 3 squared and y minus 5 squared equals, and then this distance now, the square root of x minus a negative 1 becomes x plus 1 squared plus y minus 1 squared. Y minus 1 squared. And you can literally drop off the square root over both sides, because you can square both sides. So you can drop off the square root over both sides. Right? If you square both sides. And then if you expand this, you're going to get x squared minus 6x plus 9. And if you expand this, you're going to get y squared minus 10y plus 25. That's on the left side. That's equal to, on the right side now, you're going to get x squared plus 2x plus 1 from this. And if you expand this one, you're going to get y squared minus 2y plus 1 equals. So the side here equals a side here. You have the squared terms that cancel each other. So the x squared on this side cancels the x squared on this side, and the y squared on this side cancels the y squared on that side. They consolidate the other values now. So let's say we're bringing everything. Let's say we're bringing everything over here. Bringing everything over here. So we have minus 6x over here already. Take that 2x and carry it over, we get minus 8x. In terms of the x, we have minus 8x. Then the y now, we have minus 10y over here, and we have minus 2y over here. Carry it over here, so it becomes a plus 2y. Minus 10 plus 2 is minus 8. So we have minus 8y as well. Minus 8y. The numbers them now. So this is 9 and 25. 9 and 25 is 34, right? And then them two here come over and subtract, me get minus 32. I have minus, not minus, plus. So this is 34 minus 2. That's 32. So we have plus 32 right here, so now. Equals 0. Then 32 can be divided by 8. And get these positive, I can divide through by a negative 8 instead. Divide these by a negative 8. This becomes x. This becomes y. And this becomes minus 4 equals 0. So it's basically x plus y equals 4 is the answer. That's a locus. Let me see if that's what I get. And I did it the other time. X plus y equals 4. There you go. X plus y equals 4. That's it. So again, you have this solution as well. So far, so good. Easy stuff, you know. Easy so far. Easy. So far, so good.
Yes,
Very
sir.
good.
Yes, sir.
And let's look at the next one now. Alright, so the ability to interpret what they have said, make a sketch, and then apply what they have applied the coordinate geometry method. I always call the point P, X, Y. So you can apply a coordinate geometry method. But this one says P is 3 times as far from the line X equals 8 as it from the point 2, 0. So distance from the line X equals 8 is 3 times from the point 2, 0. So you want to sketch that now. sketch it so you can see it. Alright? So, alright, see it here now. So I put it up like now. So y-axis, x-axis, right? So the point 2, 0 is on the x-axis right here. 2, 0. And the line x equals 8 is a vertical line over here. So x equals 8 is this line. So this is x equals 8. And the point now is, let's say the point is 3 times from this as it is from this. So distance from this has 3 times what it is from this. So we can put the point maybe about here and put it on in black. Let's say we put the point about here. So that this distance, let's put the point pxy right here. And I like to put 3 little lines on this to show that this side is 3 times as long as this one. And what would this point be? This point will have the same x value as this, which is 8, and the same y value as this, which is y. So that this distance is 8 minus x. That's what this distance is, 8 minus x. So the distance here is 3 times the distance here. Because this is the longer one. The longer one is 3 times the shorter one. So let's call the points some. Let's name the points. Let's say that this point. Let's say that this point is A. This point is B. It means that PB is 3 times AP. That's what it means. And that's what you're working on. And get a locus. The long one is 3 times the short one. Let's say this distance is 3 times away from that line as it is from this point. So that's what they have said. P is 3 times as far from the line as it is from the point. So the distance from the line is 3 times the distance from the point. That's what they have said. And what is the distance PB? It is 8 minus x, because the two y values are the same. So this length is just 8 minus x. So you're going to write 8 minus x is equal. What is this length now? I'm going to use the length of line formula. It becomes the square root, and it's 3 times. Sorry, it's 3 times the square root. Difference in the x value squared, that's x minus 2. Plus the difference in the y value squared, that's y minus 0, or y. That's the locus. Just need to simplify this down now. So we can square both sides. If we square both sides, we have to square that 3 here too. So this will become 8 minus x squared equals, square this as well to get 9 into, and you put back this now, x minus 2 squared plus y squared. And expand and simplify. So we expand this, you're going to get 64 minus 16x plus x squared equals 9 into, expand this now, you get x squared minus 4x plus 4. That's why you get to expand a perfect square there, plus a y squared here. So you get 64 minus 16x plus x squared. We'll multiply with a 9 here, and we get equals 9x squared minus 36x plus 36 plus 9y squared. Alright? Let's say we carry everything over here now, or carry everything over that side. So it's going to be 0 equals. Take this and carry it over here and subtract from the 9x squared, I get 8x squared. Then we have the y squared there, so, which is 9 of them, 9y squared. Then x is now. When that x 16x over here, it becomes positive. So negative 36 plus 16 becomes negative 20. So we have minus 20x. Then we have the numbers now. So the numbers is this and this. So I'm going to take a 64 and carry it over here. So I'm going to get 36 minus 64. How much is that? 36 minus 64 Same as 64 minus 36, and you negate it. So that's 14, that's 8. That's 28, right? 28 says minus 28. No, not minus. Oh, is that minus 28? 30, yeah, minus 28. Let me see if that's what I got. Let me see. That's the it, guys. So it's a matter of doing a sketch. Where is it? Where is it? See it here, sir. That's it. Yep, it's correct. Same thing. That's what I have. Can take that 28 and sorry. Can take this 28 and bring it over here so it becomes this equal 28. That is it. Same thing. See that, guys? Very good?
Yes, sir.
Alright. Let's look at another one now. Next one I have is this. So the point is equidistant from this line and from that line. So we're going to use the distance from a line formula now. The point is the same distance from these two lines. So if you think about it, it's like you have two lines going like so. The line that you want is going to be down, right down the middle here, so where them intersect. So this distance and this distance is the same. So it's going to move on this red line. P is going to be on this red line right here. That's where P is going to be on this line. Alright? But how we're going to do it? So it's like we have the line. We have the two lines. We have 3x plus 4y plus 5 equals 0. And we have the other line, which is 12x minus 5y plus 13 equals 0. And the two of them are the same distance from the point pxy. The distance here is the same as the distance here. Same distance. What's the expression for the distance from here to here? The same distance from our line form that I gave you. It is equal to this equation. Okay, you're putting back the x here and the y there. So that equation, which is 3x plus 4y plus 5 over the square root of 3 squared plus 4 squared. 3 squared plus 4 squared, which you must know is 5, equals, and you still have to introduce a plus or minus somewhere. So you equal plus or minus the distance from this line now. Because when you have two lines, you know, guys, if you have two lines like this, right, the line that is equidistant from the two of them, because the line can continue down so, and the line can continue down so, right? So one line would be a line passing through between them like here. This line will be equidistant between them. But a line passing through them here will also be equidistant between them. Because the distance from here to here will be the same. But also a distance from here and here will be the same. So the answer is going to give you two lines like that. So you have to put the plus or minus to account for the two possibilities. Alright. So the other one would be the distance from this line to this point, which will be again the same equation, plus or minus 12x minus 5y plus 13 over square root of this squared plus that squared. Square root of 12 squared plus minus 5 squared same as 5 squared. Plus or minus. Let's simplify this down. This standard used to work out to be 5. Standard used to work out to be 13. So that's a 3, 4, 5 Pythagorean triple. A 5, 12, 13 Pythagorean triple. Then put them on in red. So this standard here so is a 5. This standard here so is a 13. So I'm going to take this 5 and multiply it up here. And take this 13 and multiply it up there. And see what we get. Let me leave them on there in red. Alright. So it is 13 times 3 is what? 39. So that's 39x. 13 times 4 is what? 50, 52. That's 26 and 26, right? 52. So 52y that. So 52y. And then 13 times 5. 13 times 5 is what? 65. Equals plus or minus. We're going to 5 times these now. So 5 times 12 is 60. That's 60x. Then 5 times 5 is 25. So it's minus 25y. And then 5 times 13 again is 65. So that's plus 65. So you work it out, one with the plus and one with the minus now. So you work out the whole of this and that with the plus, and you work it out with the minus. Two of them. Work out one with the plus and work out one with the minus. And since I have it already over here, I'm not going to bother to work it out again, because I have it down here already. See it here? See the same thing I have right here, so same thing I have right here. Plus or minus. Alright? So I multiply by the 13 over here. Multiply by the 5 over here. So I'm working on two ways. I'm working with the plus to get this. I'm working on with the minus to get this. So I get the two equations. That's this one and that one. So it's there. But that is the key steps, guys. But alright with that, I think I'll present another method on here, but leave that one alone. I don't trigonometry yet. Everybody good with that?
Yes, sir.
That's the other method. So you can look at it if you want. This one now, the next one, next example down here. I'll do some past papers after this. It's this one. That one is the point P move that it's a distance of 2 units from that point. That's just going to become a circle. Where this is the center and the radius is 2. You don't have to waste time to work that one day. Alright? Simple. The distance between PXY and this is always equal to 2. So write an expression for the distance between those 2 points, put it equal to. So on the solutions, I'm just going to the solution for that one. So that one's straightforward. Distance is always 2. See it here? So the point P is the same distance 2 units from that xy there. Alright, so it here distance is always 2. So you do this and you get this as the equation. This one really easy. You create up a circle. Alright, so that is that. Let's look at the next one. This one next. That's what it says. P is a constant distance of 5 units from this line. So P is a constant of 5 units from this line. So I'm going to use the line formula. You have to care about this one. Alright, so what it is that you have the line 4x minus 3y minus 1 equals 0. And the point P is xy. And the distance between this and this is always 5 units. So the distance from the point to the line is always 5 units. So you can put the plus or minus 5 on this too, you know. So distance between those two would have been 4x minus 3y minus 1 over square root of 4 squared plus 3 squared. 4 squared plus 3 squared. That's the distance from this to this. And that's always equal to 5. So it can be a plus 5 or a minus 5. That's what you're solving. And this one here says 5 anyway. That's a 3, 4, 5 triangle. So this one here says 5. You multiply what you get. You're going to get 25. So you're going to get 4x minus 3y minus 1 equals plus or minus 25. There's two lines you're getting. One with the plus and one with the minus. Simple as that. Alright, solution is on there somewhere. There. So the same equation there, so plus or minus 5. That's it here. Plus or minus 25. So you get these two answers, one with the plus and one with the minus 25. Those are the two possible lines. Alright. I think we have one more. One more. Right here. This one says A is the point minus 1, 0, B is the point 1, 0. The angle AP0 is always a right angle. This is going to bring in gradient. So if the angle is a right angle, it means that the perpendicular, the lines are at 90 degrees to one another, so the product of the gradients is negative 1. So if we set that up and sketch it, so you have these 2 points on the x-axis, 2 of them on the x-axis. So like you have an x-axis, you have negative 1, 0 out here, and you have 1, 0 out here. You have the point P up here. Let's put on P in red. Such that these two lines, it's a A and it's a B, and they are always at 90 degrees to one another. And this point P is XY. So these two lines are at 90 degrees to one another. So the product of this gradient and this gradient is negative 1. So we can set up like this. The gradient of AP times the gradient of BP is equal to negative 1. That's what they're going to do. Now what's the expression for the gradient of the first line? It's difference in y. That's that minus that. That's y minus 0 over difference in x. That's x minus a negative 1 becomes x plus 1. Times gradient of this line is difference in y. That's y minus 0 again. Over difference in x. That's x minus 1. And that's all equal to negative 1. That's what you're solving there now. So numerator becomes y squared. The denominator becomes the difference of two squares, which is x squared minus 1. That's all equal to negative 1. Take this and multiply it up here. We get y squared equals 1 minus x squared. Bring over the x squared, we get x squared plus y squared equals this 1. That's the locus. The last one. Let's see if that's what I have here. Yep. X squared plus y squared equals 1. Good. That's it. So now it's to find the ones on the past papers. And I'll give you a minute or two to try it. And then I'll do it, alright? So let's find the past papers now. As I said, it's not on every paper. So we're going to just search. So let me see. Alright. So 2024. 2024 here. 2024. Alright, so you can search your locus. Not there. Let's try search. It's not there. So maybe not type, you not find anything whatever type. So we could search it this way then. It's not enough format you can search for words. So it's usually at the quality geometry question. (2024). I don't know if they set any in 2024. Let's look in. What I should do, I should look and see which years have it first before the class. So you go. Here's one. Easy. A point Q, here's one. A point Q moves in the XY plane such that it is equidistant from this and from that. Determine the locus of Q. So instead of P, them call it Q this time. Come on, you must can do this. Q is the same distance from these 2 points. Easy, come on. Do that one for me. Then when you finish. That's 2024. See if you can find the years that they have. Then when you finish, so I can work it out. About to finish? About to finish? This one is on 2022. I'm bring it up from now. About to finish this one? It's an easy no man, shut done already, you know. Taking so long. What if it's me alone in the class? Alexander, not finished yet. Andrew. In car. So I don't like online class. Elizabeth. Oh, son, I must not be. Hunter.
I'm
Miss
still working.
Gillespie. Why not answer? Me go in the class, you know. Because that is me alone in here. Nobody saying anything. What kind of thing this?
Sir, you're low.
Huh?
Your mic closer. Can't hear you properly.
I was low all the time from the beginning of the class.
No, well, so I don't know, like it's like your mic cut out or something. Sir.
So I've been low all the time and nobody not say anything. So anyway, how far you reach with the question? Answer that now, how far you reach with the question?
Yeah, I'm finished.
That's enough for some man, because the question easy, I waste time, you know. I want to do some more past because let me work out this one. So the point Q is equidistant from these 2 points, right? We call the point QXY as normal. So it means that AQ equal BQ. Simple. What's the distance between these 2 points? Distance formula, square root of x minus 2 squared plus y minus a negative 5 becomes y plus 5 squared equals, what's the distance between these 2 points, the Q and the B? Same thing, square root of x minus a negative 2, which is x plus 2 squared plus y minus 3 squared. Can drop off them square root here now. To square both sides. I don't need them actually. But then if you expand this, you're gonna get x squared minus 4x plus 4. Expand this, you're gonna get y squared plus 10y plus 25. That's what the left hand side will equal to equals right hand side. And expand this, you're gonna get x squared plus 4x plus 4, and expand this, you're gonna get y squared minus 6y plus 9. What cancel each other now? X square balance x square here, y square balance y square. Let's bring over everything to the left side. So we're gonna have minus 4x, and that first come over here and drag minus 8x. So we have minus 8x. Then the y now, we have a 10y here, and minus 6y come over and become plus 6y. And then 6 is 16y. And the constant now, this one is 29. But firstly, a 4 here and a 4 here wipe out each other. Alright? So I can literally underline those two. Wipe out each other. And so I'm left now with 25 minus 9, because this 9 comes over and subtract. 25 minus 9 is what, 16. So with plus 16 equals 0. And you can divide through this by a negative 8 to get rid of this. So divide by a negative 8, divide by a negative 8. This becomes x. It becomes minus 2y. It becomes plus 2. No, divide by a negative 8, so it becomes minus. equals 0. And that's the locus right there. Nobody got that? Nobody got it?
Yes, sir.
Alright, good. We'll do this one over here. It's from 2022. It has some make the screen bigger. Here it is. To that one. Point P xy move the xy plane such that it is the same distance from the point 1, 2 as it is from the line x equals 3. Draw a sketch and do it. Do that one for me. Let me see. 6 past 4, given until 16 past 4, 10 minutes. It's about 2022. Everybody finish? But I finish that one.
Almost finished, sir.
About 5 more minutes, but I'm supposed to finish already.
Finished.
Finish. Um, let's check another one before. Let's find. Let's make find another one. That's one. Let's try. It's cheaper. Find another one so that as soon as I finish this one, I can give you another one to them. Let me see. Mm, 17. 3 more minutes. All right, the final one. 2016. I put up after. All right, ready? Ready, guys? For this one, let's sketch it out, right? So the point P move in such a way, XY move in XY plane such that it is the same distance from point this as it is from this line. So let's sketch it out. So that you have your coordinate geometry system like this. And x equals 3 over here, x equals 3 at the point 1, 2, and here. Alright, and then the locus now is the same distance. So about here. So that this distance same as this distance. This point we're gonna call it PXY as usual. So this point here we have this X value and this Y value. So this point is 3Y. So this distance is 3 minus X. And I know to get distance between these 2 points already. Now let's call this point B over here so we can reference it. So it means then that the distance AP is equal to the distance BP. Now AP is the distance between these 2 points. Same formula again. Square root of x minus 1 squared plus y minus 2 squared. That's all equal to this distance, which is just this length across here, which becomes this x value minus this x value, x minus 3. That's what we're solving. So I square both sides and get x minus 1 squared plus y minus 2 squared equals x minus 3 squared. Let me shift this up. And then simplify this. Expand out this side first. You get x squared minus 2x plus 1. That's this. And this one now we get y squared minus 4y plus 4. It's all equal to this side is x squared minus 6x plus 9. Then the squared terms cancel, or this x squared terms cancel. That's this one and this one. And we're going to consolidate the values now, right? So this is all the y squared there. That's y squared. And then you have, this is the next y term, that's minus 4y. X now. Now this 6x goes over, become positive 6x. 6x minus 2x is 4x. And then in terms of the numbers, this is 5. Remember the 9 and subtract. 5 minus 9 is negative 4 equals 0. That's the equation of that locus. Nice and easy. But go to that.
Yes, sir.
It's easy, 6 marks for that, you know. Easy stuff, 6 marks for that. Alright, next one is on 2016. Let me bring it up for you. 2016. See there? Even your, this one says, point P must, says that the distance from x-axis is half the distance from the origin. This distance from the x-axis is half the distance from origin. I'm going to do this one, and I'm going to call it a day. I'm going to look for another one first, before I call it a day. Let me look first. Alright. Let me look first. Let's see if we see any other one. This is 2016. There was one on 2015 or so. I was asking about a search from the paper search. Let's switch it up for this 2016, 2015. Give me 10 minutes to do this one. It's now 4:20, giving it till 4:30. 10 minutes. Easy. Make a sketch of what they have said and work it out. The distance from the origin and the distance from the, let's say, point P moves such that its distance from the x-axis is half its distance from the origin. Make a sketch and work it out. Right? Distance from the origin is half the distance from the x-axis. Make a sketch and work it out. Ready, guys? Ready? Hello?
Yes, sir.
Alright, so this one I want to sketch it up, right? Point means such that its distance from the x-axis is half its distance from the origin. Alright, so let's set it up. So y-axis, x-axis. So if I put it here, so the distance from the origin is half the distance from the x from the o. So I like it right here. Distance from origin is long, alright? So I like it here. So put it here, so pxy. The distance from the x-axis is this. Distance from the origin is this. Alright, what I'm saying, the distance from the x-axis, which is here, is half the distance from the origin, which is here. Now, what is this distance? This distance is just y, you know. This distance is just y. It's not even working on. This distance is just y. What is this distance? Distance from the origin to this point. This distance is just the square root of x squared plus y squared, because here says x, you know, and here says y. The question said the distance here, the distance from the x-axis, which is y, is half. Let's say it again. The distance, point P move such that the distance from the x-axis, y, is half the distance of this. So basically what they have said is that y is half this. So y, that is this distance, is half this distance. That's the locus. This is your locus. You can simplify it. Put 2y over here equals the square root of x squared plus y squared. Then square both sides, you get 4y squared equals x squared plus y squared. Subtract the y squared here, we get 3y squared equals x squared. That's the answer. Simple as that. Everybody see that?
Yes, sir.
Marks for it. 5 marks just to that. So if it's an easy. Easy. Right, let's look 2015. 2015. Right here. Here you go. This one's straightforward. Point P moves such that its distance from a fixed point 0.3 is twice the distance from a fixed point 5.2. Show that the equation of the locus is a circle. Alright. Yes, do this one for me. Let me see if there's any other one on in 2014. I don't think there's any in 2013. I don't think locus came onto the syllabus first here. Let's set the exam. Try this one for me. It's supposed to be one on 2014. Let me see. This is what you're doing, guys. This. 1 year too. 1 year. This is 1 on 2014. So can do them 2 year. Let me try it. I don't think there's any on 2013, but let me check still. We'll do this one first on the screen, the 2015 one. Let me try it if there's any on 2013. Yeah, I think those are the last two. Alright guys, let me do it. And you can do it over by yourself. I'm going to do it right on the screen here, so. Let's take a small space. Alright. Last one is very straightforward, so I'll do this one quick and fast. So the point is P. Let's call this point A. Let's call this point B. What did it say? It said the distance, it says P moving such that its distance from A, that is AP, is two times the distance from B. That's 2 times BP. That's what they basically said. I must prove that the locus is the equation of a circle. Now, a circle is an equation with an x squared plus a y squared in it. Or, can we write x minus a squared plus y minus b squared equals r squared. It must have an x squared plus a y squared in it. Or, that's the highest powers in there. So that's what we're trying to work out. What will be the distance AP between these two? it will be the square root. And you can literally, to forget about the square root, you can square this and square this, such that this square become 4 times this square. But you can leave it still. Leave it as that. So what will be this distance? It will be the square root of x minus 0, which is x squared, plus y minus 3 squared equals 2 times BP now is the square root. It's between this and this now. That's x minus 5 squared and y minus 2 squared. That's it. So we're going to square both sides, expand and simplify as well again, right? Trying to get the equation of a circle. Square both sides first to get rid of the square root. So square this side. The square side we're going to be on. It's going to be turned 4. So you're going to get x squared. We're going to expand this. We're going to get y squared minus 6y plus 9 equals. We're going to square this side now. It's going to become a 4 into the square side will be gone. We're going to expand this out now. So we'll expand this first. We're going to get x squared minus 10x plus 25. Expand this now. We're going to get y squared minus 4x plus 4. Ready now? So it's going to become 4 times each of these, right? So you're going to have 4 times x squared here. So care about x squared, you're going to get 3x squared over here. So 3x squared. We have 4 times y squared, and carry this over, you're going to get 3y squared. In terms of the x values now, there's no x value over here. This is the only x value. Well, it's supposed to be a y, no, not x. It's supposed to be a y. That's a mistake. This is y. Expand this to get y. But you're going to get 4 times minus 10 is negative 40x. And then, it's 0. Oh, I'm going to reach the thing there. Then the y is now. You're going to get 4 times 4. That's minus 16. And you have minus 6 over here. So the minus 6 comes over, become a positive 6. So minus 16 plus 6 is minus 10y. And the numbers now. The signs are 29. And then this 9 going to come over and subtract. So 29 minus 9 is 20. So you're going to get plus 20. I have 0 left on that side. Now, if I divide 2 by 3, I'm going to get my x squared plus y squared. Divide 2 by 3, I'm going to get 0 equals x squared plus y squared minus 40 over 3x minus 10 over 3y plus 20 over 3 equals 0. That's the equation of a circle. So you have an x squared term and a y squared term. You have an x and a y. That's the equation of a circle. So you have fraction and so on. But that's the equation of a circle. That's a circle. And so I've shown that it is the equation of a circle, locus. That is it. Very good. But okay with that? Not hearing anybody?
Yes, sir.
Alright. I think there's one more on 20, 40. An easy one. Sit here, so. Come on, I must do this in 5 seconds. A point P moves on the XY plane such that this distance from this is always root 2. You must know this one. That's just an equation of a circle, If you have this root 2 from this, it's a circle, this is a center. And let's write that one is x minus 2 squared plus y minus 3 squared equals the radius, and the radius becomes this distance. That's root 2 squared. That's the equation of that one. And moving a fixed point around a point, moving a fixed distance around a point, and moving on a circle, where the point is the center, and the distance from the point is the radius. Simple as that. That's what it becomes. But alright,
Sure.
I'm gonna end the class now. I'm gonna send the video to the class so you can redo the questions for me, alright? But that is it for today. Tuesday we're starting. Is that a vectors or trigonometry? I'm starting the class on Tuesday. I'm not sure yet. And we're not gonna have a class next week Sunday. I have a funeral next week Sunday. So we're not gonna have a class next week Sunday. That's why I'm forced to have the class today. But we'll have class Tuesday and Friday. Alright? I think we're gonna start vectors or trigonometry. Either way, we need to do either one we do, we'll have some vectors in pure maths to do separate from odd maths, and some trigonometry to do as well in pure maths separate from odd maths, but they all start at odd maths level. But see you all on Tuesday, guys. Have a good evening. I'm gonna send the video, read the questions out, please. Alright, bye.
Bye, sir.
Bye, sir.